Now that we've created our trails, it is time to create some debris. Usually a good way to create debris is with a particle system. The advantage of using particles rather than rigid body dynamics is that it can be changed quite easily, it is calculated very fast, and is usually very flexible. So in this case, we can start by using something similar to the pop trails. So let's make some space here. I will move all these nodes. And I will copy the pop trails network and paste it. And I will rename this one pop debris. And the first thing I'm going to do is change the substeps to 1. I'm going to dive into the network, and I also want to change the amount of particles emitted. So usually with the debris, we only want a single burst of points rather than a constant emission. So let me turn off the auto update here. I'm going to change this to manual. On the pop source attributes, under the constant activation, I'm going to change the value to 0. And on impulse activation, impulse count, I'm going to increase the count to 40. Also, one thing that I may not need here is a turbulence. So I will just delete this node. So remember, this debris will be bigger and heavier than the sand trails that we created. So probably they won't be that much affected by the wind. And speaking of wind, we can bring down the pop drag to something very low, for example 0.02. For now, let's leave the rest as it is. So I will go back to frame 1, turn on auto update, and let's press play. Okay, so now I have much less particles, and as I mentioned before, I don't want the particles to continually emit. I'm just going to find the first frame, or even the second frame. We could use frame 8 and 9 to emit the particles and stop after frame 9. So let's find under activation. Remember, we're using impulse. You can type the following H script. $F, which is a frame number, is less than 10. So this will evaluate to true from frames 1 to 9, and from frames 10 and up, it will evaluate as false or 0. So let's take a look at the particles now. So we just have a very small burst of particles, and they will immediately start falling. So let's try checking the velocity inheritance for the particles. So go back to your pop source, attributes. So right now we have a very low velocity inheritance. Let's increase this to 0.9. And also I want to add more variance. Let's increase this to 5 meters. Now this is much better. I probably went too far with the velocity inheritance. Let's bring this down, say, to 0.7 or 0.6. And also one thing that I noticed is that the particles are disappearing. So in case of the debris, we don't want the particles to disappear. So let's go back to birth. Let's find the life expectancy, and let's bring it up to 100. This way they will never disappear. I think we can go with this. It's looking fine. So let's continue by instancing some geometry on the particles. So go back to your sub level. And here I have pasted beforehand some very simple geometry. So this will be on the sample file for you to use. This is a piece of brick shattered with the Boolean tool. And actually we have 4 different pieces of brick. And if you're curious, I just created a box. I added a small bevel. Then I divided the block. And on the other side I have a sphere. I added a mountain and just repositioned it to an interesting place. Then I booleaned both objects. And centered them into the grid. This way, when they start to spin, they spin from the center of the geometry. Finally, I added UVs, a material that is also included here. It's just a simple gray shader. And that's basically it. So I have 4 different geometries. Okay, so back to the instancing. We usually want a p-scale attribute. So we can borrow that from here. We already did a randomized p-scale. So you can copy this wrangler, paste it here. Now remember, we're scaling these original particles with the age. In this case, the debris won't scale over time, so I will just remove these lines. And the bricks were modeled on a 1-to-1 scale, so they have realistic dimensions. So although I'm going to randomize the scale, I don't want to go very high. So let's scale the particles from their original size, which is 1, to say 2.5. Now let's add a copy to points. Connect the points on the second input and 1 piece of geometry on the first input. Overall, the instance geometry is looking fine, although I may change the scale a bit, and also it will greatly benefit from some spin. Now, if I go frame by frame, you will notice that most of the time the instanced objects are kind of static in the sense that its orientation is usually very uniform. So let's take care of the scale first. I will change the p-scale attribute. And actually I will go from 1 to 0.5. Or 0.75. Okay, so let's add some spin. Now, the spinning motion of a particle is usually stored in a W attribute, similarly to how the velocity is stored in the V attribute. So let's define this before we enter the particle simulation. So I will lay down an attribute randomize just before the pop network. Call this node setW. And here under the attribute name, just type W with lowercase. And under the distribution, select inside sphere. Now we can go into the DOP network, and I will add a pop spin node. So what this node does is it rotates the particle through time along a predefined axis. So let's change the spin speed to 360, and this will generate an entire turn over 1 second. So let's take a look at the geometry and see the results. So I'm going to press spacebar 2 just to take a look from the top view. And you will notice now all of the bricks are rotating more or less uniformly around the y-axis. So they all have the same orientation and the same speed. So let's dive back to our pop network, and I will change a few parameters for the pop spin. First of all, let's increase the speed, say to 720. And now what we can do is, rather than using the same axis for every single particle, we can use the W attribute that we already randomized per point. So you can type the following: axis, which is the variable for the axis parameter, is equal to @W and semicolon. So press Control Enter to evaluate the script. Go back to the SOP level and let's take a look. So now notice how each point has a different rotation. Although they're all spinning at the same speed, we now have a more randomized look. So let's try also randomizing the speed of each particle. Dive back into the DOP network, and this time the parameter that we want to change is the spin speed. And if you hover your mouse over this parameter, you will notice that there's a variable called spin speed that will control this value. So for now, let's change this value to 0, and we will override it with a vex expression. So after my W attribute, I will type enter. Spin speed is equal to 3600. And now type semicolon and press Control Enter to evaluate. So go back to our SOP level. Let's take a look from the top. Okay, now all the bricks are spinning very fast, but again they're all spinning at the same speed. So let's randomize that now. So instead of hard coding this value to 3600, we're going to use the rand expression with the ID attribute as a seed. So remember, we'll have a value from 0 to 1, and we can multiply this value by the 3600. Now each point, based on its ID, will have a randomized spin that can go from 0 to this value. So again, let's take a look. Let's go to the camera view. And now we have some very fast rotating particles, like this one, for example, and some spinning much lower, like this one here. And this is starting to look very interesting.